One of the most commonly misunderstood geometries in any CAD is a profile for a cylindrical cam. So a lot of people just try to do an emboss to create the cam slot, but that actually doesn't result in the correct geometry. If you think about the geometry, it's actually as a cylinder rotates around in an end mill, rotates around the part, or the part rotates as the end mill translates to cut that geometry. So the tangent point between the cutter and the face of the slot is continuously variable. At this position, it's at 12 o'clock and 6 o'clock position, but as it goes around, it will move up here or move along here, depending on which direction that you're going. But the tangent point is continuously variable as we start to go up along this. And plus, we are going towards the center of this. And so we can't just do a sweep of a rectangle, and we can't just do an emboss um, to get this in one shot. It actually takes a couple of shots because the only thing that really truly known is the centerline path of this tool to generate the displacement diagram. So let's go ahead and play this. Now, right now I have two cams over top of each other. I have a correctly created cam, and then I have one that's incorrectly created, and the difference is really subtle. I'll show you how to find the difference, but it's particularly on this geometry, it's really difficult to see. Let's go ahead and run this though. So I'll tell it to animate the joint relationships. Now, because this is fairly complex geometry, it's a little bit slow in calculating at some of the transition points. So it'll go around and it'll until it gets to a difficult calculation, and it'll stop for a second, and then as it continues the calculations, it'll keep going around. So let's look at the difference between the blue cam and this gray cam as far as the issues. So I'm going to go to a section view, and let's see, I want to get it. It isn't really as interesting through where it's going through the flat side, but it is where it's going in a rise or a fall. And so I'll come around here and I'll look at this in a rise or a fall, and you'll see a slight difference here with this line. This line's horizontal. This is the incorrect. This one's actually going up a little bit. In the same way down here, as that falls away, this is going down. And if I turn on a sketch to make that a little bit more visible, let's see if I got my sketch over here someplace. I'll go to my sketches, and I've got a sketch here at the end. Let's turn that on. And so um, if I project both of those, so we have that line, let's add a line to that so we can see this better. And so I'm going to turn on, I've put in a construction line in here, and I thought it was in here. Maybe it's over here on the other side. Okay, let's turn off the body geometry for a minute. And so I'll turn off that cam visibility for both cams. And let me get the other one. Okay, so you see this is horizontal. The closer we get towards the center, we see this curve uh, goes up, and then this curve goes down the closer we get to center. And it's kind of a subtle thing to see, particularly on this one, which isn't very deep, but that is the true shape that is cut as a tangent point with the cutter uh, begins to either go up or go down or translate as this is rotating. Again, you can verify this, go out in the machine shop, cut a cam in half. This is what you're going to see. So let's look at how to do this. And let's go a couple more steps here. And I have a picture of a displacement diagram on a canvas. And so let me make that canvas visible. And I don't know why it didn't show up there. I forgot that I was in a section view. I'll turn off that section view, and we'll look at this. And so here I have a canvas, and maybe make that a little bit more uh, darker so we can see that better. And I'm going to bring that over to visibility. And so the temptation is to model the slot and emboss that or do a sweep, but that isn't the correct way to do it. The only correct way is to model only the path of the cam follower, so only the centerline path. And so that's what I did in my first sketch. So I'm going to turn on that sketch. I'll turn off the visibility of the canvas, and I need to go around here and actually in my first sketch I actually put for the depth of this. So the depth of the cam, let's look at that. And 5 millimeter depth, the height of the cam, and a hole diameter. And then here's the diameter of the cam itself. And so if I put my mouse over there, it tells me that that's D1. And so I'll use that in a formula because we know that the circumference is pi times the diameter for the cam. So I'll go to my sketch number 2. So I create a work plane uh, parallel to this plane at this point or this point, and then create my second sketch with the uh, displacement diagram. Now notice that I put a line across here to split this and this into two sides. So this is my center line path right here. Okay, so that's my center line path. I put a sketch in here, or a rectangle. I put it with it centered at the, or the center of the rectangle at the origin. And let's go ahead and look at the dimensions on that. So I'll edit that sketch. I have a transition here, radius 40, and then a straight line rise, and then a fall transition 50 degrees, and then a straight line section, and then a arc again, and then another straight line. This line and this line are equal to each other, and they're 15 millimeters from the bottom of the rectangle. Now, when I created the rectangle, I dimensioned this as D, the diameter, D1 times pi to get the length of that. Okay, so you sketch in your displacement diagram, whatever it is, only the center line. Once you have the center line, bisect it, and I'll show you why you need to bisect this in a second. All right, and so I'm going to finish that sketch, and then you can move sketches around in the timeline. So I did some other sketches for some circles. So this is the diameter of the cam and the cam slot taken projected from the first sketch, and we'll see how I use those in a minute. And then I did another sketch for the follower and for the shaft that the cam rotates on. I'm going to turn that one off for now, and I'll probably turn one of these others off for now. Turn that one off for now. We'll come back to that. So first thing I do is rotate the thickness of the slot for the cam. And then I'm going to do an emboss, but I only emboss, I'm not doing the width of the follower. I'm only embossing to the center line of the cam. That's the only thing that we know is valid, is that center line displacement diagram. And I do this in 2 steps. So this is why I did the vertical line. If you try to emboss this in 1 step where this and this wraps around, where this point hits this point, it will give us an error. And it does that in every CAD program I think that I've used to do this with. So that's why I split it into 2 embosses. And emboss cut that on both sides. And then I'm going to do an offset surface. And so I create a surface body, and I offset that half of my thickness. So this is the center line. this is the center line. Let's turn off that displacement diagram. Okay, this is my center line of the displacement, and then this is offset for the side of the slot. Offset that face. Now that offset gives us the correct geometry, where if we try to emboss that directly, the geometry is slightly different, very slightly different, but it won't work. This is correct geometry. And then I'll do another offset to the other side. Okay, so that gives me the full width of my slot then. So offset half to one side, half to the other side. Now I put a little bit of clearance in here. Actually, it's easier to control the uh, dimensions of the follower than it is to control the dimensions of the uh, the cam path. So you might put your tolerance, your in the pin itself on the follower. That's going to uh, be easier to machine to a specific size. Let's turn off the visibility of that body for a minute. And then the next thing I do is I extend out this surface. Let's go back and let's look at that again. So I have my two offset surfaces, define the top and bottom of the slot, and then I extend this. Now the reason I extend this is when I go to make the cam slot, if I extrude that, it isn't going to be perfect. To 16 decimal places, this circle out to that, because see this surface, let's go back a step again, and I need to go back here and go back one more. Okay, so it looks like it's perfect compared to the circles, but it has to be perfect to 16 decimal places, or 15 or 16. Otherwise, when you try to do the extrude, in fact, I see here that it doesn't go to that circle perfectly. So we have to extend that surface a little bit in both directions. And so that's what, well, you might only have to do it in one direction, but I did it in both just to be sure that I don't have to fool with it. And then the same thing with the bottom one is we offset that and then we extend that. And then I'm going to remove this construction geometry, this body this was just to find the center line path of this cam. And so then once I have that, then I offset it and I delete the original. Then I'll extrude this circle. And so let's turn on sketch number 1. And so I'll extrude that circle, or that two circles. This is the slot depth. And when I do that, if I edit that feature, I do that starting up here. That's my start position. And then I say to object and select the surface over here. Now you have to select it over here, not over here on the screen. Select the surface so it extrudes down to that surface. Okay? And then we'll do the same thing for the bottom side. So if I edit that feature, I extrude from this point on the bottom. This was in sketch number 1, and that's my object that I start from, that point. And then I extrude to object, and I select this second surface. Now again, if we didn't extend those out a little bit, it would probably give us an error. And the amount that you extend it really isn't important. You can go with a really tiny amount. That I just need to make sure that it caps this extrusion when it gets up to that surface. All right, I can turn off the visibility of these two surfaces now. And then I'll extrude the center portion of the cam. So I'll extrude this circle inside here from the top to the bottom to fill that all in. I have one solid body now. And then I did a revolve of the axle that this is going to spin around. And then I do a revolve of the follower. Okay, now here we see the follower there, and then I converted these all to components. Okay, so I converted all those to components. So now I have an axle which I have grounded, and a cam, and then I have the follower pin. Let's turn off those sketches. All right, now I put a constraint. Now you can either do this with a joint or a constraint to put this pin in location so that the only thing it can do now is slide up and down. It can't translate anywhere, only slide up and down. Now I want to make sure that I get in here where it's not in an interfering condition. So if you zoom way in on this, you'll see that I left a little bit of clearance here, a little bit of clearance here between the bottom of the cam and the follower, and a little bit of clearance up here at the top. Okay, so that only translates. And then I did, and now this is a little trick. I wanted to keep this. I wanted to keep this in the middle of the slot. And so what I did is I offset this space by the distance of my clearance between the pin and the slot. And so if I turn that visibility on, so that'll go to my cam. And so I created this offset surface. And so it's up slightly. It's up the height of my clearance to put this pin right in the middle between the clearance at the bottom and the clearance at the top. We have to have a little bit of clearance or friction would not allow it to move. And then of course you don't want it touching this face either. There will be a lot of friction. All right, and then I put in another constraint, and let's look at this second constraint. So the first constraint was just to keep this so that it only moves or translates. The second constraint I did is to do a tangent, and I did a tangent between the face of this cylinder and the face of the offset surface of this surface. Okay, not to the cam itself. I had trouble if I put it to the cam itself, actually. Sometimes it would flip to the other side because there's two possible tangencies. There's a tangency with it in this position, and then with it down here, there's another tangency on the other side of that. When I put in a surface offset, it seems to be more robust holding it in that position where it doesn't flip. But you can still have a situation where you move things and it would jump to the wrong side. And also I set this to all faces of that surface. And so not all faces of the cam, but all faces of the offset surface of that cam slot. If you have a situation where this jumps to the wrong place, simply go to that constraint, the tangent constraint, and suppress it. Move your follower in about the right location, and then unsuppress that tangent again. It'll pop back to tangent. Now I can move this. Actually, I still have another constraint that I need to put on here for the revolution. And so that gives me that revolution joint between the cam and the axle. And so now this rotates. Now, if I rotate it by mouse, it may or may not keep up with the calculations. That's where it could get lost and it could pop to the wrong side. I'm able to move it sometimes all the way around, just moving it by mouse without it popping to the wrong side. But you're better off if you just run this, let the computer control it. And so I'm going to tell it to, I need to find that joint. And so I'll tell it animate joint relationships. And so here we go. And so it stops there for a second as it does a calculation, on that ramp over there. And but it's more robust if it's doing the calculations rather than you dragging by hand, and you could accidentally override the calculation position and then it gets into the wrong position. Again, if it gets into the wrong position, let's hit escape here, you simply suppress the tangent, move it around to its, in the easiest places where it's dwelling, where it's not moving up or down, and get it more or less in position by eye. And then if you unsuppress that, it will pop that right back into position for you. So that's doing a cam in Fusion. Now at some point we should be able to do a sweep with solid. And so we should be able to tell it to do a sweep, a solid sweep, and then actually cut the slot with a representation of the cutter. But I tried that earlier today and I couldn't get it to work. Um, and so we have to do it the hard way for now.